Good morning, everyone. First, I apologize if I'm looking a little bit sleepy. That's because it's quite early here in Brazil. But anyway, I'm very glad to be talking about a project I developed last year with a few friends. It's a project about COVID-19 mostly, but I think more importantly for this conference, it's about data visualization, how people relate to data, how they not relate to data, and how can we as communicators use effective techniques to have the impact we want to have. And first, I want to give you a quick recap of how COVID-19 played out in Brazil. As you may know, Brazil had a very severe COVID-19 situation. We are currently the second country with the most deaths in the world. We have around 600,000 deaths. In the worst days of the pandemic, we're seeing 4,000 deaths a day. And it was quite scary. But if you were in Brazil back then, you would have this uneasy feeling that people weren't taking the crisis seriously enough. In big part, this is because of the way our government handled things. You know, we didn't have very intense containment measures like some countries in Europe, virtually no lockdowns, virtually no, there was a mask mandate, but it wasn't enforced. And as a communicator, this was concerning to me. Of course, this is a political decision. This is something to do with policy, but we could also see that in the way people behaved, people were still living as normal life was going on, even in the face of those huge numbers. And as someone who works with communication and numbers, I used to ask myself, how is this possible? How are people ignoring those huge tallies that we communicate every day? And maybe this has to do, at least to some extent, with the way we communicate those numbers. You are seeing right now a screenshot of Jornal Nacional, which is the main news broadcast in Brazil. It's broadcast every night in prime time. It's huge. I think it should grab 70 or 80% of all televisions in a single night. And every day they would present a lot of data. You are seeing now the moving average for September last year in Brazil, the moving average of deaths, not cases. They would also present stuff which is very important to get a grasp of how the pandemic plays out, like the reproduction ratio of the virus and even the spread of the virus throughout the Brazilian states. And this, of course, is very important. You need to follow these numbers closely as a journalist if you want to understand how the disease is playing out. But on the other hand, as a viewer, this might get tiring and repetitive soon. And this reminds me of a concept that Stephen Few, a database consultant, calls quantitative numbing. The idea is that when you report ever-increasing numbers in the same fashion, you don't get a higher response and a more concerned response, but you get the opposite. You get people getting desensitized to information. And I have a nice anecdote about this. As many people, when the pandemic started, I moved from my city in São Paulo back to my parents' house in a smaller city. And we would watch this news show together. And my father, he would pick up the TV remote controller when these reports were going on. And he would ask everybody to be quiet. He would put the volume up, so he was paying attention to the numbers. He would wait for it to end. And then he would resume talking about whatever, about the previous soccer match or about his work or about anything else, really. And this is something that he usually did when he was younger, when watching the weather forecast. So everybody be quiet now. We are seeing the weather forecast for tomorrow. And then he resumed living as usual. And I can't really blame him. This screen grab is how a weather forecast looks like on national TV. And it's very, very similar to the map I just showed you about COVID-19 in the States. It has the same aesthetic. And maybe if you want to overcome data numbness, this quantitative numbing, we need to think of another aesthetic and another formats to present our data. And this is what our project, which is called No Epicentro, at the Epicenter in English, is all about. Basically, it adds more context to those numbers and very personal context. This is the first screen you see when you open it, just to give you a quick summary because we can't go into details because of the limited time. The project is based on a single question. What would have happened? How would it look like if all COVID-19 deaths in Brazil were your neighbors? So in this first screen, the user is asked for his address or actually any other address. And then we start a simulation and we draw a huge circle on the map showing how far would the devastation go, the area around the user, how the people wouldn't be alive anymore if the situation was real. Now you're seeing a GIF which shows somewhat how this plays out. First, he inputs his address, and then we start drawing this circle, ever increasing, that shows how far would that go. Every single white dot inside of the circle is a dead neighbor. This is my former house in São Paulo, a very densely populated place. And this works because, as you probably know, urban data is also very personal. People have an understanding of the neighborhood. They know how dense it is. They know how it works. This is the place where they catch their buses, where they go to work, where they visit their friends. And you have a very intuitive know-how about the scale of the depths when you show it this way. We also did the same for the United States after doing the original project in Brazil using United States data. It was published in the Washington Post. As you can see, the visual language is almost the same. We also had very positive results, which goes to show that this idea of using land and place of living and urban data as a visual metaphor for COVID was really powerful and really effective. And I would like to walk you through, the whole experience. There's more than these GIFs and screenshots, but I can't do this because of time. Here's the link for the Brazilian version of the project, and here's the link for the American version. Now I want to go into the coolest part, since we're in a data conference, is to talk about how we made it, what were the decisions behind it, how the team was composed, and how we put everything together. So basically, this project was first commissioned by Agência Lupa, which is, interestingly enough, a fact-checking agency in Brazil, and it was supported financially by Google News Initiative. We had a lot of people from those two teams working together, too many people to name. I'll name just a few: Natália Leal, Alberto Cairo, which were very important as editors and art directors. But in the end, the core development team came down to three people: a journalist, which is me, an engineer, which is Thiago Maranhão, and a designer, which is Vinícius Sueiro. And this project is really in the intersection of data journalism, code, and design. That's why you have these three specific competencies in the team. But we were not operating like these three separate dots, which was very important, is that we knew how the areas of our colleagues used to operate. I am a journalist, but I also code and know a bit of design. Thiago is an engineer, but he has an eye for telling visual stories. Vinicius is a designer, but he used to work in a big newspaper. And so we were able to connect our skills in this very interesting way that allowed us to build a very cohesive narrative. Telling stories with data is very, very multidisciplinary, and we couldn't do something as successful if our skills weren't talking to each other in this very organic way. It was also very important to draw inspiration from the right places. I can't pretend and say that it was a very original idea. I think it has some merit. We were the first people to think about presenting COVID deaths on this way. But as this cute Pokemon you're seeing right now, Mr. Mime, I think our main power was to mimic what other stories did best and put everything together in a new format. One of the maps that inspired us is this map by the New York Times. It's actually quite old. It's from 2016, and it shows the results of the 2016 election in a different way. At the left, you see all the land that Trump won, and the holes are the counties which Hillary Clinton won. And on the right side, you see the opposite. And as a map, this has some limitations. Probably we are talking about elections. We would like to see the population density of those places. We would like to see, because in the end, Hillary Clinton had more votes than Trump. So it has some limitations as dataviz regarding precision, but this image is very powerful. This idea of vanishing, of using terrain. Another important inspiration was this map by Plano C, which is a Brazilian data consultancy. And the idea, the name of the project, is Here Nobody Lives. And all these orange dots you are seeing are places where there are no single person living, and all the Brazilian population is concentrated on the white squares. And this is important because it gave us the idea to use the population distribution as useful information. This is a very nice map. You can zoom in a lot, you can explore, you can see the dynamics of your city. So we taught us that population density is actually quite cool. Very important also was this map by Virginia University. It's a racial dot map made with the US Census data. And basically every dot you're seeing here represents a person, and the color represents its race. So You can see how some neighborhoods in New York are mostly white, some are mostly black, some are mostly Latino. But the key thing we took from here is the idea of representing each person as a point. Aggregate data is very powerful to understanding patterns better, but when we present each data point in a data set as a single visual element, it's easier to relate to them. It feels more personal, it feels more human, even if they are just a dot. And I think the closest thing to what we have is this project by outrider.org, which mimics what would happen if an atom bomb went off on your city. So you can see how the look and feel of this project is very similar to ours. Basically, you pick a place in the city, and then you see the radius of the detonation, and you see as well how far the devastation would go. And by putting everything together and mixing that with our own ideas and experimenting a lot and ideating a lot, we came up with the final version of the project. Technology-wise, it was not very complicated to make it. There were 5 main technologies: Python for the backend, for the calculations of the radios, Mapbox for the visual presentation, and the usual web technologies for web design, HTML, JavaScript, and CSS. And from the hardware side, not all the project, everybody had its own, every person in the team had its own computer, of course. But the heaviest data processing was made on this laptop here. It's quite old. I think it's like 10 years old. It's running on Ubuntu. And we had to improvise this cooler here with Lego pieces because the computations were intense for the computer. But what I'm trying to show here is that we didn't need to do any crazy stuff for cloud computing or amazing hardware to make our project. It was all actually quite simple and quite doable, even with a team of good developers, but which are not that specialized. And it's also open source, and it's also reproducible. I mentioned how we reproduced that with United States data. It was easy to do because we have the code already available on our GitHub page. And as long as you have census tract data, you can make it for any city in the world. I believe it would work well because, as I told you, this reference of urban space is very personal, and I dare to say it's almost universal. If you have census data and COVID-19 data, you can make it for Prague, for any other place in the world, for anywhere else, really. And now let's talk about data. It was very important to have very detailed data. I will walk you through the data sets that we used. First and foremost, I need to give a shout out to these folks here, Brazil.io. They are a group of programmers that basically their work is to scrape data from many health authorities in Brazil and present the total COVID deaths in open format. This is very important because in the beginning of the pandemic, we had a very slow response from the federal government, and having this reliable, organized numbers was actually very hard. So a shout out to them. But the main data source was the Brazilian Institute for Geography and Statistics and the census tract data. Basically, we use census tract data because we know the details of the population in bigger cities. It comes down to the block level. So we are seeing the city I am stationed right now, Ponta Grossa. It's not that big as São Paulo, but for every one of those squares, I knew how many people exactly live there. And this is important because I didn't want to use bigger tracts or maybe even city or district population estimates because we wanted things to be real. We wanted it to reflect street level data, not something that was further away from the reality of the reader. Because you live on your street, you don't actually live in your city. You live on the most granular level possible. And this is how it looks like in the backend. Basically, the computation has a few steps. We set up the location, we fly to the destination, and then we start drawing these ever-increasing radiuses and start computing the intersection between these radius and each one of the census tracts until we reach a target number of, which is the amount of deaths in a given point in time. So the radius keep increasing until it has around, say, 100,000 people inside. And then we add the points according to the population distribution in each census tract. So this is how it looks in the back end. And in the end, we did all of this, which you may criticize it in many ways because it's not really accurate. We were using census tract data from 2010, which was the most recent available. It's somewhat fictional because these deaths haven't really happened around this place. So there's a lot of criticism you can do to this piece in terms of accuracy and the way the narrative was built, but it had a goal in mind, which was to have a very specific type of impact, to make people understand the scale of the crisis. And I think it was able to do so. I have some tweets, those are in Portuguese. I'll move on to the English ones. And the words people were using were actually very telling. They were using words like green, breathtaking, heartfelt, and they had this very emotional response, which was intended, but they also commented that this sort of visualization allowed them to see the pandemic in a new light, see the pandemic in a way that they weren't able to understand before. And this reminds me of a researcher, a journalism researcher I like a lot, Nikki Usher from the University of Chicago, on her book, Interactive Journalism, which is very interesting. It's about how journalists work with data all around the world. She has this concept of near view and far view. What is the near view? The near view is the immediate reality, how things affect a person on the individual level, its family, its block, its close friends. And the far view is the broader view, the things playing out in a national level, connecting the dots. And she says that one of the main strengths of data journalism and data in general is that it's able to guide people successfully from the near view to the far view, from the immediate reality to the broader trends. And I think this piece does this well. We weren't thinking of this when we made it. We just came to this realization after. But I think it's sort of the main driving force behind the piece. If you're interested in more technical details and more design decisions and code decisions, we have this piece in the GIGN website. And it's very lengthy and it goes step by step into the data decisions, data cleaning, and data processes we had. And hopefully by the end of this experience, people in Brazil were no longer looking like this, like hiding their eyes with their masks. Thank you.